beads from the proximity ligation reaction. It's somewhat variable, and we know that for the kit we would like to be kind of in the 500 nanogram type of range. But we also know that we want to do the QC1 now to find the kind of the functional ligated products, and we need 75 nanograms to do that. So that's the question. Do we really want to spend 75 nanogram when we only have 300 of the whole sample? So if you are on the low side like this, and maybe even there, let's say below 500 nanograms, you could just skip the QC1, save that 75 nanograms, and just go on into the library prep. Right? But we are doing it now just to see how well we have done our reactions. Right? So keep that in mind. Don't waste 75 nanograms.
Can you not do QC1 on a smaller amount? I mean, in theory.
Smaller amount?
Of DNA, like, instead of 75, you adjust
Yeah,
the reagents.
I guess you can, but sooner or later it will be inaccurate, right? I mean,
We were discussing with Graeme. Now we are going to see if we really have the biotin in the DNA.
Yep.
If we don't have that, why we are going to proceed?
Yes, but then again, if this is the sample you have, you have no more tissue left to repeat the cross-linking. I would rather go in with what I have and take my chances, because I have already spent most of the cost now, right? The remaining part is just kind of a standard library prep, basically. So why not just finish it and see what I get in the end?
If it's your pressure samples. That is why we are going to do with ULI, right? We are not going to do QC1 in ULI, and we are going to proceed anyway. So.
So this is a QC beads in the Arima kit. So we are taking 50 microliters of these beads and are mixing that with our 75 nanograms of sample, right? So the first, I do this on strips because we need to incubate. If you see the protocol, we are mixing beads and sample, and then we are incubating during these wash steps at 55 degrees for 2 minutes. It's very handy to do that on a PCR cycle and use a multi-channel for the washing when you have at least 8 samples. So what we can do, we can start the
But you could use a heat block if you want to as well.
You can. We incubate for around 15 minutes for the QC1s to bind to the biotin on our DNA.
One question. The fragments that are not ligated, we have something around fragments are ligated?
Yeah, not all of them are ligated, no. You will never have 100% ligation efficiency.
So it is, we are measuring how much DNA this biotin.
Yeah.
It's funny because when I when I looked at the diagrams before, I thought that all the biotin was only attached to the fragments that were actually those linked,
Yeah, but
you know?
it's actually those we are interested in, right?
Yeah, but it's not always that. You
No.
have others that were not properly cross-linked,
Yeah.
they will come in.
Yeah.
That's what
But the chance of having two DNA ends that are in close proximity,
yeah.
there's a higher chance that these are ligated than something that are far apart physically.
And if they are ligated, then the biotin cannot get in.
The biotin is on the nucleotide
Yeah.
that we are introducing during the proximity ligation reactions.
Okay.
So the biotin is kind of bridging the ligation ends. And these are the ones we are fishing out in this next step. A portion of those relative to the overall DNA. So now we have incubated our samples with the QC beads, and then we are putting it on the magnet. It's maybe not the easiest magnet to see the separation due to the color, but there you go.
You could just glue some stripe of paper, wet paper.
That's a very good tip. Okay, I check. This seems to be pretty good. You can see that the beads are on the side of the tube towards the magnet.
Ish.
Okay, we are removing the supernatant from this. We put the tips on the front of the tube wall, and we follow the surface of the liquid with the tip and suck off carefully like that. You see, this is a clear solution, so the magnet are stuck to the beads are stuck towards the magnet side of the tube. Okay, then we take it off the magnet, and now we see the tube, the beads there, right?
Oh, okay.
They are quite small, those bead pellets. And then we take 200 microliters of the wash buffer, and then we resuspend the beads again. It takes a couple of pipetting up and down until you see that you have a faint color of your liquid. That means that you have gotten it into suspension again.
It's getting beige.
So we put it in the cycler.
For what degrees? How many degrees?
This is 55 degrees for 2 minutes.
For 2 minutes.
I think the incubation, it improves the washing, I think, and it stabilizes the biotin structure within kind of reaction, which, by the way, is very efficient. Okay. And then back on the magnet. So if you look now, it's a bit still a bit hard to see due to the color of the tube and the magnet, but it's quite easier to see the bead pellet on the back there. It's kind of more fuzzy now during this wash. I think it means that we can go on. There you are. It's a bit more easy to see this time. Okay, we put it back on off the magnets. And now we just repeat what we have been doing. We wash once more with 200 microliters of wash buffer, incubate for 2 minutes at 55 degrees. we are washing one more time with elution buffer. So this is how it looks for the last wash. I inspect the tube so I don't have any, large droplets or kind of things further up on the tube walls. Okay. If you see on the magnet now, we have used another buffer, and suddenly you see that the beads are kind of more smeared on the tube wall. They are not kind of more concentrated as we saw earlier. So you see the supernatant is clear, so there is no bead there, which is good. I just make sure that I have removed everything. You see there is some sort of concentration of beads there, but you also see this smeariness of the remaining of the bead. It's very dilute, this QC beads solution we're using, so it's the bead palette is small anyway, kind of.
So you're scraping beads from the side.
Yeah, because
with
now
the tip.
we are kind of eluting into a very small volume now.
Yeah. So we are helping with the tip.
So we are kind of doing like that, just to make sure that we have all the beads into the solution. And then I do some pipette mixing. What's important here when you do the qubit is that you mix this solution, and then you right after take out the 2 microliters for the qubit, because if you wait too long, this will sink down, right? And then you will have a non-homogeneous solution, and you will have an inaccurate result. Now they are a bit dry, so it takes longer for them to resuspend fully. If that happens, you just have to take the time to do it properly until it's fully homogeneous. It's better to leave it, after some mixing, it's better to leave it on the bench for 5 to 10 minutes and then repeat the mixing if you are in doubt. So what I've noticed is that the krill samples are more difficult than the herring. Explain that.
Ha! Krill be krill. Right, so what have we done? We have cross-linked that to the nucleosomes, and then we chopped with the restriction enzymes all around, but we don't know how these restriction enzymes, how far did they chop from nucleosomes, because the DNA composition could be different. Krill genome is extremely AT-rich and very repetitive. We don't know anything about the chromatin structure of the krill. That could be that we have longer pieces of DNA around nucleosomes where restriction enzyme didn't get. So that means that we have longer fragments in krill sample, which means that they might be more tangled or something. Or the beads might be clumping because the proximity between chromatin junctions are shorter. Maybe there are some proteins left, so decross-linking was not as efficient as in herring. Or it could be that there are some like AT loops around, so the restriction enzyme is cutting somewhere out, but there could be some loops that were sitting outside, so it can be different 3D structure. of the hydrated DNA. So we'll see.
Solution buffer, yeah.
Regarding to the density of restriction sites, it's something that you could do bioinformatically when you
Yeah, in silico restriction, if you have a good genome.
this is or a slightly
Yeah,
decent.
yeah. This is
This
not
super
decent.
high.
We are doing another qubit quantification, but we are doing that on the bead suspension. That's different. It's not a clear illusion now. We do it on the bead suspension, and that's the DNA that are clinging to the QC1 beads, right? That's what we are after. So this is the 7 microliter bead suspension that we are taking 2 microliters aliquot of and measuring the concentration. So when you take out the aliquot, first put a pipette at 6 and do some pipetting up and down. Have a smaller pipette to take out the 2 microliters aliquot. Take it out right away after mixing, and then you're done. You could actually, if you put your tube on the vortex, kind of right, pointing right up, right? You can just give it a short vortex and then put it directly into the qubit instrument, because then the beads are in full solution. You will get the measurements.
Okay, so we don't have to wait 2 minutes on incubation?
Yeah.
We do that, okay. The other
During
after
incubation,
okay.
they might precipitate.
So we have to work that before putting in the machine.
Yeah, that's one way of doing it at least.